Okay, so recording. An electron accelerated from rest through a potential difference of 1250 volt. If the potential difference is half, calculate the ratio of new speed of electron to the original speed of electron. Okay, as you can see here, got two conditions. One is new speed, another one is original speed, right? So if you have two conditions, you need to divide into two columns, 1 and 2. Okay, so originally is 1250 volt. Okay, that is V1. V1 is 1250 volt, and then potential difference is half, so become half of the V1, which is 625 volt. Okay, half. So what is the new speed of electron? So we are using electron. Okay, what is the new speed? So this is a V. This capital V plus, and this is small v. Okay, so I don't know the v here. This v2 I also don't know. So I want the ratio. That means I want ratio. Ratio of new speed v2 over v1. I want this ratio. Can you find that? Okay, how to relate between v and velocity and voltage? The formula to relate is this formula: EV equal to half mv square. So from here we can see electron charge and mass of electron is constant. The variable is only voltage and velocity. So we can say voltage is proportional to velocity square, and then we can make a relationship between volt and velocity. So we can make it like V1 over V2 is equal to if voltage at the top, because this one is corresponding to each other. So if voltage at the top, velocity also at the top. So this one you put V1 square over V2 square also, because they are at the same level, voltage and velocity at the same level, like that. So if V1 at top, velocity also at the velocity 1 also top, voltage 2 bottom, velocity 2 also bottom, like that. Okay, so we can have this equation. So this is 1250 over 625, and then this one is V1 over V2 square. So cut this one is equal to 2, and then we have V1 over V2 is cert2. Okay, but however this question he want new speed to original speed. New speed to original speed, that means we have to invert this, become V2 over V1, so it's become 1 over cert2. Okay, 1 over cert2, or you can write this as cert 1 over 2, or you can write this as cert 2 over 2. Okay, that's the answer. Is that correct? V2 over V1. Yeah, V2 over V1 is this answer. Is it correct? Yeah, that's the answer. Cert 1 over 2. That's correct. Okay, that's correct. Now, how about the B? What's the ratio of new wavelength to original wavelength? So you want the new wavelength to original wavelength. That means dia nak apa? You want the lambda 2 over lambda 1. So what's the answer? Yeah, new wavelength over original wavelength. So let's find out. New wavelength to original wavelength. How should I do it? Okay, this one I put it the other side over here. Okay, so this is just now is question A. So question B now. Yeah, question B now. New wavelength. That means I want the lambda 2 over lambda 1. So how are you going to do it? New wavelength over original wavelength. Yeah, I'm going to use this formula. Lambda equal to H over mv. Okay, H over mv. So from here, mass of electron is constant, but we can see lambda is I can say is inversely proportional to velocity. Understand? So I can put it like this. Lambda 1 over lambda 2, lambda 1 over lambda 2 is equal to, so if lambda at the top, velocity at the bottom. See that? So lambda 1 at the top, velocity at the bottom. So v1 bottom. Now lambda 2 at the bottom, then velocity 2 at the top. Okay, like that. Like that lah. Understand? So you have the answer. Lambda 1 over lambda 2 is lambda 1 over lambda 2 is v2 over v1, which is sert 1 over 2. Sert 1 over 2. Now he want new wavelength to original wavelength ratio. That means lambda 2 over lambda 1. So I need to invert it. Lambda 2 over lambda 1, so it become sert 2 only lah. Yeah, 1 over this one, you get sert 2. So that's the answer. Is that correct, class? Question 4, 4b, sert 2. Yeah, sert 2. That's correct. That's correct. Okay, very easily done. That's all. Just find the relationship. Bye.